So let's begin with the pendulum one, and just say me whether you get an idea about that. Because if I just read that question, it's just an ordinary one. Now this is our pendulum, something like a pendulum, and usually the mass will be at the end. But in here they are saying the mass is somewhere located in a portion like this. That's the only difference. Did you try that answer? I think question number 4, I think. The pendulum one. They have said a point mass is placed at an unknown portion of a narrow massless vacuum tube of length L. The length of this is L. Length of this is L. And there is a certain mass located at an unknown distance. So they have just approached the question in that way. So they are just making oscillation at different points from this end and the opposite side of that. And they are measuring the periodic time. So the main question is, we have to find at what location this mass is. Did you have tried? Alright, it's fine. So if you look at here, the entire length of this is L. There is a certain mass at an unknown distance. So let's say from one corner it is at a distance x. The distance of him is x. And now if I start to make oscillation, it is something like a pendulum where the length of the string is x and we are having a mass here. Okay, if I repeat it, I am making oscillation from this end. So the length of the string is x. I am comparing it with a simple pendulum. The length of the string is x. The mass is something like the pendulum. Now, if we measure the periodic time, they are saying it is t. Okay. So they are saying us, similarly, when the rod is allowed to oscillate about the other end, the oscillation period is 2t. Now, when he is oscillating about x, he is getting t. Now, can you say me what is this remaining distance? Because he is making oscillation from this end. So, what is this distance? That's going to be L minus F. All right, let's take that answer. So, it is L minus X. So, if I just compare with another pendulum, the length of the string is L minus X. And the mass is located at the end point. Now, if I start making oscillation with this simple pendulum, I would obtain a periodic time such as 2t. That's what they have said here. So with this information, we should start the question. Okay. The periodic time is given. And we have somewhat idea about the length in terms of L. Now here it's L minus X. Here it is X. So now let's start to write expression. T is equal to 2 pi square root of L over G, but it represents the length of the string. Is the board clear? Not right. So T is equal to 2 pi square root of L over G. L represents the length of the string. So the length of the string is X divided by G. So from here, I'm able to write this expression. Using this, let's write an expression. The periodic time is 2t. It is 2 pi square root of. You should understand it is L minus X, the length of the string. So it is L minus X over G. So now we are able to get two expressions. Let's find an answer for X. So this is equation number 1, equation number 2. So equation number 2 over 1, I will be obtaining 2 is equal to 2 pi cancel off. Square root of G will cancel off. I'll have L minus X over X square root. So now you can see that I'm desperate enough to find the value of X. So, but I'm having a square root here. So now I'm going to square both the sides. So I will obtain 4 is equal to L minus X over X. Okay. So now you can just cross multiply. 4x is equal to L minus X. My answer for X will be L by 5. But be careful. They are not asking the distance of X from one end. They are actually asking you that what is the distance of the point of mass from the center. Now let's see if this is the center. It's going to be exactly half of this entire length, which is L by 2. L by 2 is the half of the length. This represents X. So from the center line, they're asking you the measurement. So be careful. It is L by 2 minus X will get you this distance. Okay. They're asking you from the center. So it is L by 2 minus X will be the answer for you. So from the center, it will be L by 2 minus X, which is equal to L by 2 minus L by 5. L by 2 minus X, 5L. 3L by 10, right? Okay. It has to be 3L by 10, okay? From the center line, L by 2 is the distance up to this point. This part is X. So L by 2 minus X will get you this distance. So it is 3L by 10. That has to be your answer, okay? Are you okay with this? And yeah, what happened to answer? But 12 by 5, right? Both is the approach, or did you make any mistake in between? That's what they have just said you that what is the distance of the point mass from the center line? Okay, so it's fine. Okay, just that. Yeah, that's it. So it is 3L by 10. I think I did the next question that related to pressure part. What about the friction question? Two blocks each of my same. So shall we move to the next question? If you're done. Right. So let's move to the next friction part. Yeah, I think we have tried a similar question behind that. This side. So you must be careful in here. There is a block, and below that there is also another block. They are providing force only to him. Okay. So if you just read the question, two blocks of each mass, M. So both have the same mass, kept one over the other. The flow is frictionless. The coefficient of static and dynamic friction are mu and mu k. Sorry, mu s and mu k. And we already know that compared to static coefficient, dynamic coefficient is lesser. Even they did not provide this information, get an idea behind it, okay? Initially, both the blocks are kept at 2, which graph correctly shows the variation of acceleration A with the force. Okay. When a constant horizontal force is applied on the block, which is at the bottom. Now, I think there's a small mistake in behind that. Say why it is. Now, they are just dragging this object with a force A. The flow is frictionless. We don't have friction in this area. In this section, we don't have any friction. In this section, we don't have any friction. But there is friction in between these two. So let's try to mark the friction behind them. What will be the direction of friction for this mass? If I name A and B, what will be the direction of friction on A? Is it towards the right or towards the left? Yeah, it's going to be towards the right. I just teach you why it is. Because since he's having a force, the entire system is going to have an acceleration towards right, which means the mass A should travel with an acceleration towards right. So the friction is going to help him in this case. We'll be having friction, and the opposite reaction will be given for the mass B. Okay, so just figure out how you're going to mark them. Right, so now get an idea. Now, usually we used to deal with static and dynamic. Now, static is when the object is at rest. When the object is at rest, we have these coefficients. And when the object is moving, we'll be having dynamic coefficient. But you should understand, in here the friction is considered in between, not in the flow. So what does this static friction mean? Do you get an idea behind that? You know, when static friction in the sense, the object has to be rest. But you can see, right, it is moving. So what does this static and dynamic say in here? Yeah, fine. Okay. Now see here, as I said, static friction means, yeah, obviously the object is at rest. But you can see both of them are moving. So what does it actually say is they don't have any relative motion. Both of them are moving. It's fine. But in between them, there is no any relative motion. So it is not like you're dragging him. He is not sleeping in this case. It's a case like that. You are dragging him. Simultaneously with him, A is also moving. There is no relative motion between these two. Okay? So it is like if he is at rest, he doesn't roll over him. He is stuck in between these two guys. So when there is no relative motion between A and B, we'll be having static coefficient. So get an idea behind that. Okay. And now when you're having relative motion, we'll be having dynamic coefficient. So just note it down as a point, okay? When friction is present between two objects, okay? Because we have been learning with the flow. So when it comes in between two contact surfaces of two objects, the scenario is quite different. The frictional force between two objects in contact is said to be static or limiting. Is said to be static or limiting when there is no any relative motion between them. So that is even the exact definition for static, okay, static frictional force. Even the flow and U, there has to be no any relative motion. But to get a clear idea, even all levels, we'll be learning object is at rest. So just get the brief idea. There has to be no any relative motion between A and B. So in such cases, we have static friction, whereas, whereas dynamic coefficient is present. Dynamic coefficient is present when there is a relative motion, or when the object slips, or when the object slips. So you might have observed in rotational motion, under no slip condition, there won't be any relative motion between the flow and the object. But actually it is rotating. So it's rolling, okay? Once it is rotating, it is moving as well. So there is no relative motion between the two surfaces. So we say no slip condition, there will be static friction acting. So it's a similar case like that, okay? Actually, both of them are moving, but if there is no relative motion, we have static coefficient. If there is a relative motion, we have dynamic coefficient. Let's see what will be our answer. Okay, so they're asking the acceleration of form, which graph correctly shows the variation of acceleration A with force. Right. So you should get an idea. Let's write the equation. Equation. So let's write it for A now. So you can see you are having frictional force. Frictional force is equal to mass into acceleration. This is the first case. When you're having dynamic coefficient. Okay. So they will be having static friction between A and B. And this will be my answer. But be careful. When you're writing for the next times, it will be a scenario like this. A will be having an acceleration, let's say A1. B will be having a different acceleration, like A2. That will be the difference here. That is what known as relative motion. If they are having the same acceleration, relative acceleration is 0, and relative velocity also supposed to be 0, because the starting point is the same, right? But when they are having relative motion, they'll be having different accelerations or different velocities. So now when you write the equation, I have dynamic coefficient. It is FRD, which is equal to MA1. And also I said they have made a small mistake. A constant horizontal force. Let's see why it is. So we are up to here. Now look at what, if I just write the equation for the entire system, you can't write for the entire system. Okay. I made a small mistake in this case as well. You must be careful in writing these expressions. Every time now, of course, you're not a math student, right? Now, when you're writing this force equation, it has to be written with respect to an Earth observer. Now, this A1 is measured by him. So that's the main problem in this case. You can't write it that way. So for now, I'm just leaving him. So if I just draw the graph for only this part, so just note down at that as well. For the linear momentum, whatever equation, you have to write with respect to Earth, not with respect to some observers. Okay. So when you just draw the graph for the first part, if I'm not changing the friction, so if I'm not changing the force, friction won't change. Okay. But they have said you that a constant horizontal force is. That is a small mistake. So just have it as let's have it as just a normal force F, okay? The force can vary. So in the first part, we'll be having friction increasing with the force. A case like this. And now, you have to get an idea what's going to happen. There will be a maximum point, of course, the limiting friction. Even in that case, both of them have the same acceleration. But now, we are having dynamic coefficient on him. Okay? We are having dynamic coefficient on him. So nicely observe things. You can't write it this way, as I say. Let's write the relative acceleration. If I write it for this guy, for B, F minus Fd is equal to mass of B is also the same, M times A2. Now this is measured with respect to Earth. F minus Fd is equal to M times A2. Now let's observe for him. If I write for B, B is also having the same acceleration A. It will be F minus Fs is equal to Ma. Now this is when you are having static coefficient. F minus Fs is equal to Ma. Okay. F minus Fs is equal to Ma. Now when you're having dynamic, F minus Fd is equal to Ma2. And just change the question as acceleration of B, okay? We are measuring the acceleration of B. If not, it won't. Okay, so there are two mistakes. It's not a constant horizontal force. It's just a varying force. Because you can see the force is varying. And also just write acceleration of B. So in here we are having F minus Fd is equal to Ma2. Now you can see that static coefficient is greater than dynamic coefficient. So compared to this value is quite greater. Then Fd will be lower, okay? Dynamic coefficient is lesser. So Fs is greater than Fd. So okay. So of A and A2, who will be greater in this case? Now here we are having F minus Fs is equal to Ma. Here I'm having F minus Fd is equal to M times of A2. So of A and A2, who is greater? And if you did not get that, the same way. Yes. Now see here. Now let's say a fixed value. For force is 5. Static force is like 4. Now when the force is the same 5, dynamic coefficient is, let's say, you know how it will be greater than Fs. So it is 3. So 5 minus 4 is 1. Whereas 5 minus 3 is 2. Okay. So 5 minus 3 will be 2. So you can see, and make sure that you're going to remember it as a pattern. When the friction is, when there is a subtraction, when the other side part, the minus part is getting lower, our answer will anyways increase. Now see here, the force is getting lower. So my answer is getting greater. 5 minus 3 is 2. So A2 is greater than A1. Just note that point. So compared to A, A2 has to be greater. This has to be my answer. Okay. I think we tried a similar question like this. So all up to here. If you feel confused, just I have shared another question. Just try it. If you have in doubt, just say me, okay? Of course, there are some
So
errors in
which
this
paper is
question.
this?
I don't know when I shared it. Say let's see it next. Just share the question PDF, okay? I can't remember when I shared that. That's the last PDF.
Okay, so I just wanted to know that.
Okay. Not paper number 10. I think after that one. Okay, I'll just repeat the last one. What actually happened was, as I said, just take some fixed values. Let's say the FP, capital F is 5. Static force is 8. And that 5 is again present here. 5. But you know, compared to static friction, dynamic friction is lower. So let's take a smaller value than that. If it is 4, let's take a value like 3. So 5 minus 4, you'll be getting an answer like 1 for A. 1 over M, that is equal to A. For A2, you'll be getting 5 minus 3, which means 2. So you can see, right? Compared to 1, 2 is greater. So this answer has to be greater than this answer. Okay? So be careful in that case. That's why it's considered A2 is greater than A1. And the friend, just go through the recording. Okay?
Okay, sir.
This 2 questions I just finished. And have you covered relative humidity? Because that's a question in that as well. Okay, so is everything fine? So just try the previous question and again try it. Then you'll get a somewhat an idea. So of course, there are some errors in this question as well. Okay. So the only point which I want to say is get the exact idea of the definition of Fs.